It's gonna be nice to do this in front of friends, so I'm not like too nervous.
We are
But
friends.
yeah, not friends. So today we're gonna be talking about Arduino. Arduino is an open source framework basically for microcontrollers. And so what that means is basically anyone has the rights to use this. And that's why you see a lot of off-brand Arduino stuff. So for example, this one's Key Studio. It's still a quote unquote Arduino board, has all the things that Arduino has. It's just from a different company. And so you might be thinking to yourself, oh, gee, what is a microcontroller? Well, basically, it's a little tiny machine that can do like small computations. It's like a little integrated circuit. Um, and if you don't know a lot about circuits, that kind of stinks because a lot of this is circuitry. But Dr. Slayton has an amazing electronics class that you can go learn stuff like that from. But I wanted to focus on the actual microcontrollers on the Arduino board here because the Arduino board itself is not a microcontroller. It has microcontrollers on it. And so there's a really, really tiny one. I don't know if you can see the camera right here. And this microcontroller actually allows you to plug in your USB adapter and connect your like software interface to the actual hardware. And this big microcontroller right here is the one that actually does all the computations and things like that. And so that's what we're working with over here. As you can tell, there's a bunch of different like separate pin areas, and those all mean different things. So these pins up here, these are all your power pins. And so you can choose between 5 volts and 3.3 volts for the Arduino. Like I said, for this kind of microcontroller, you're not gonna be doing very big projects. And so this is about as much as you need. If you do need any more, you can use an external power supply, which would look something like this. I don't know if you guys can see it, and you would put batteries in it, and you can use that on your breadboard. And we'll get to what a breadboard is in a second. But for right now, we're going to focus on the actual. Oh, knock something over. Okay. We're going to focus on the actual Arduino board itself right now. And so the next set of pins we want to go to is the 0 through 13 pins. And as you can see, there's a ground pin right here as well. That's just another one of these power things, power pins. But the 0 through 13 pins, those are the digital pins, and you can get digital information from them. And so anything like what we're about to do in a second is blink an LED. Those can be used as output pins. And basically what you can do is send power to them and wire up a circuit to be sent through that pin. And that circuit will, of course, do its thing and power the LED. It's worth noting that there's little tildes on these. Those pins can be used for different things. Hey guys. And also, there's a lot of, semantics when you get into when talking about the Arduino board. They also have these things, which I didn't really know about, the TX and RX, and those are for reading serial values, which is pretty cool. So if you ever want to read any serial values or binary values, you can do that with that. And so I mentioned earlier about a breadboard, and for all of you in the classroom, this is like what a breadboard is. But we also have one right here beside our Arduino. And it might be actually easier to show this one because it's a little lighter. But what a breadboard is basically under this panel, it has metal strips connecting these little pins. And so it's a lot easier to hook up circuits if you have wires like this that you can just plug in and use it as basically a conduit for your current. Um, so how breadboard works is you can tell there's a red stripe and a blue stripe down here. And the red stripe is generally used for power. And this entire rail right here is connected via like the metal strip I was talking about. And so if you wanted to hook up power, instead of hooking up 5 volts on the Arduino every time to wherever you wanted to go power, you could just hook up 5 volts to the power rail and then plug in wherever you wanted to go via this whole entire rail. The blue rail is the same way, but it's with ground. So instead of hooking up the ground, because you only have a limited number of power and ground pins on the board itself, but these kind of act as substitute, areas for your ground to run the entire rail. Now this is where it gets a little interesting. These pins right here, they're connected vertically. So all 5 of these are going to be connected like this, but horizontally, they're not connected at all. And so that's where it kind of gets a little bit confusing sometimes. If you ever want to have like a circuit like that connects to multiple ones, to multiple, I don't know what I'm trying to say, but you want to have it connected like here and then here to be connected to each other. But if you want a completely separate circuit, like earlier, I mean, later on in the lecture, we're going to talk about LEDs and potentiometers. We're going to have an LED hooked up on one of these, or we're going to have a potentiometer hooked up on another completely separate one, because we want to keep those separate. So that is kind of the basics of the hardware. Um, Diving into the software a little bit, we can kind of resize the screen. And um, all of you in here are familiar with C++, and that's what the Arduino IDE uses. And so it's very standard data types or int, long, float, anything like that. Addison, you know what those is? But what's interesting about the Arduino IDE is it has this little setup and it has a loop. And the setup is where you're going to put all your things that are static. So anything like setting up your pins to be output or input, setting up your serial monitor, which is basically like a console in your compiler that you can write out to. And your loop is the thing that's going to repeat. So just think of the loop as like a while true loop. And then as far as declaring variables, I find it best practice to declare them outside both of these, kind of keep everything separate. And so you can have your declaring part, your setup, and your loop. And so that's pretty much it with this. There's a lot of cool little features in here. I'm pretty sure if you go to, where is it? There's your, when you're hooking up your actual board, you want to make sure this board and port are compatible with your computer. And so you want to set up your port to be just whatever. Usually it's the only one on there if you're doing something right. And then of course your board is Arduino Uno. It says they're on here. And so there later on we'll talk about some examples you can get into. Because the Arduino IDE has example code you can pull from. And so all you have to do is build the circuit itself and then run the code from your computer. But today we're going to be writing all the code because that's what's funnest. And so let's start building our first project now that we got all the basics down. Oh no. Okay. So, as I mentioned, oh, drop my LED. Microcontroller is an integrated circuit, so we want to basically build a circuit on the breadboard from our Arduino. And so, does anyone have any ideas on how you would do that? Colby?
Hook up power ground.
Okay, so you want to hook up the 5 volts and the ground to the rails? It's a good idea. So I'm going to use in this lecture, red is going to represent the power and black wires are going to represent ground. So this red wire is going to go from, I don't know if you guys can see this. I can barely see it. I'm over here. This is 5 volts right here, the pin. And I'm going to try to see if we can get like right here. This is going to go on the power strip. And we're going to take our little black wire and we're going to hook it to, and this is hard to see. We're going to hook it to ground, like so. And like I said, since this whole rail is connected, you can kind of plug in these anywhere on the thing and then use them how like so. So what's next? What else do we need to do? Actually, our first project is we're going to blink an LED. So that might give you some ideas on something.
Let's put the LED on.
Yeah, let's put the LED on the board somewhere. And so, like I said, you want to put the LED. I don't know if you guys can see this.
Further away.
Okay, there you go. You can kind of see that. This LED has 2 pins, but you can kind of tell one of these pins is longer than the other one. And so what you want to do is put the longer pin on the power side. So we're going to go ahead and hook this up. And like I mentioned earlier, you don't want to hook it up vertical because all the vertical ones on the breadboard are connected. So hook it up horizontal. So like so. There we go. Just kind of pop that bad boy in there. And then we should probably hook up the power to the long side of the LED and the ground to the short side of the LED. Yeah?
This is what I was just about to say.
Well, you would be wrong.
Try it and see what happens.
You would be wrong if you did that. But we need some kind of resistance between the circuit because this circuit is flowing 5 volts. Okay. And obviously, this little LED, that's way too much for the LED. So we need some kind of resistance. Yeah, we would blow the LED, not blow it up, but we blow it out if we use 5 volts. So let's use this little thing called a resistor. And let's see if I can put it under here. This little thing has a color code on it. And will tell you how many ohms of resistance you're putting out. You can't really see the color code. But yeah, maybe that will work. Anyway, everyone here can see the color code, probably. And so a really popular little piece of paper that's not it, that I carry with me all the time is this little color code matching the ohm resistor. So it's like a little table that tells you the color code of the resistor, and then it tells you how much resistance it has in ohms. And so for this particular resistor, I tested it out before y'all got here. I didn't really check the resistance. Probably a bad practice, but it worked, so we're going to use it anyway. So let me make sure I have the long side closest to you guys. And so you just need resistance wherever you can get it in this, whether it's going to, I'm going to have to get on top of this so I can see it, whether it's going to power or ground. For this LED, the resistor just needs to be on one of the legs. So you can have, because you know the current is flowing, and so you just need to have resistance on one of the legs. And so once we put that resistor in there, it should be good to go as far as when we get the circuit completely wired up, we'll have enough resistance for the LED to light up. So now the next step is actually completing the circuit. And so to do that, I'll connect this into the resistor leg to the power rail, and I'll connect the ground end of the resistor, or I'm sorry, the ground end of the LED to the ground rail. Look at that. But we can also, that's actually, oh yeah, okay, so we can also do stuff to make this LED do stuff. We can also make this LED do stuff by sending outputs to the pins. So right now this is just hooked up to 5 volts and ground. But what if instead of 5 volts being the power source, what if we made a pin the power source? And so let's try that. I'm going to take 5 volts out, and I'm actually going to put the pin on, I think this is 8 right here. So obviously nothing happened because we don't have any code yet. We don't have any code that says, hey, make this 8 an output pin and make voltage basically flow through the circuit. And so we're going to have to set that up right here. Everyone can see the IDE? Okay. So anytime you start coding in Arduino, first thing I like to do is set my variables. And so the only variable we're going to have on this is the pin, because that's what you want to set to output. And so just like I said in C++, you're going to use data types, and it's going to be the int data type. And I'm just going to set this to red LED. And my red LED is pin what? 8. And then with semicolon, standard practice. Setup is interesting. You have different functions in Arduino that are specific to its IDE. I had a link on my computer that I was going to go to, but we had some technical issues, so we had to end up using Caleb's computer. But if you just look up Arduino functions online, you can see a lot of those. But to set up pins as an input or output, you want to be, I mean, it's pretty simple. All you have to do is say pin mode. And then we want to, it takes in 2 parameters. It's going to be what number the pin is, and if you want to set it to an input or an output. And so we're going to use our red LED, and we're going to set this one to an output because we want output voltage. And so it's useful to note right here, if I just wanted to not set a variable and put 8 right here, it'd work the same exact way. But we like using variables because we like practicing good coding practices here. And so that is the second step. And the third step is actually, what do we want to do with this LED? Do we want to just make it blink like the 5 volts did, or not blink, but we just make it turn on like the 5 volts did? Seems kind of boring to me, if you ask me. Maybe we want to do something a little different. Maybe we want to make it blink or something. See what I'm guys getting at? See what I'm getting at? Okay. Okay, so we want to make it blink. So to do that, we use this function called digital write. And like I mentioned earlier, these pins are digital pins. So you can use them as digital input or digital output. And we're using them as a digital output, as I mentioned in this part up here. And so this also takes in 2 parameters. It takes in the pin again. So we're going to put our red LED pin. That's obviously pin number 8. And this next parameter is just a binary, either a high or a low. So do you want to send voltage to the pin, or do we want to no voltage come through the pin? 5 volts, 0 volts, either way. So we want voltage to come to the pin. And so this code right here is the exact same as basically hooking it up to 5 volts and just leaving it like that. If I ran this code, it would do that. And I can actually show that right here. If it compiles correctly, if I load it on here. LED turns on. I don't know if you guys can see that on there. But the LED turns on. It's exactly like we had it with 5 volts. But like I said, that's kind of boring, you know, whatever. And so we want to make this thing blink. Can anyone think of ways we can make this go between high and low? We're in a loop, so it's going to automatically loop itself. Okay, so digital write at red LED low. Okay, well, if we did that, let's try that. Actually, I really could have just copied and pasted, but I didn't.
Use a sleep function.
Exactly, a sleep function. And Arduino is not called sleep, it's called delay. So just keep that right up here. But yeah, using a sleep function is the way to go. So we want to delay, and this takes in milliseconds. So how long do y'all want to delay for to make the LED blink? How many milliseconds? 1,000 milliseconds in a second, by the way. 1,000? Okay. So we're going to delay for 1 second. And we want to make sure we delay at the end too. So when it goes to low, we want it to go back to high. So let's delay at the end for, ooh, I almost did 2 seconds. Do that, let's save it up. And these little buttons up here, I've been using them, but this is basically the compile button. So it tells you, does your code have any errors? If not, then you can go and upload it to your board. And so that's uploaded. Look at that. God blinking. Right. That was pretty simple. That wasn't too much. That's kind of an introduction to how you can do very simple things with Arduino. This is just an LED. But next, we're going to use this thing called a potentiometer. And I can kind of show you what these look like on camera. So if you guys want to look on camera. Oh, and I'm not even getting close. So it's a little twisty thing. The scientific word for a twisty thing. And you can twist it back and forth. And what this acts as is what we call a voltage divider, which is literally dividing voltage. And you can change the resistance going between the potentiometer by twisting it. And so that's pretty useful for, you know, making things go up and down. And so instead of having either a high or a low LED, we can use this to make it go in ranges in between. And so let's try to do that. I'm gonna leave this LED how it is, but I wish if I put I'm gonna use a different potentiometer than the one I just showed you guys, and it's gone. So this is the one we're gonna be working with. It has a little arrow on it. And it has 3 pins on it. So can anyone tell me what they think the 3 pins are for? 2 of them ought to be fairly obvious because you have to power the pin. So 5 volts or however much voltage you're sending to the pin, and then ground. But we actually have a middle pin in here too, and that's for reading the value in between. And so this goes all the way down to 0, all the way up to 123. And that is why it goes up to 123 is probably, we're not going to get into that today, but it's basically 2 to the 10 binary value to read analog to digital. And so we're going to go ahead and plug this in a place where you guys can see it. Maybe right here would be nice. And remember, we don't want to go this way because these are all connected. We want the 5 volts, the ground, and the read to be separate. So let's go, let's put this at the very top, actually. Let's go right there. I'm gonna, okay, I don't know if that's, okay, I think this is 0 right here, all the way to the left. And now I'm gonna try to power this thing. We're gonna use the red on the end to go to the power rail. We're gonna use the black on the other end to go to ground rail. And ooh. And then I got that shaken up for you guys here, but these set of pins right here are very important for this because these are what we call analog to digital pins. And so what that means is basically taking an analog value and converting it to a digital value. And so these pins are what we use for this over here. The analog value being what the potentiometer is doing, and it converts it to the 0 to 1023. So we're going to use A0, and we're going to plug it up right in the middle here. Whoop. And so we should have everything set up. Here, I'll actually show you guys here. Yeah, that's kind of a better view. So we should have everything set up. You see the guys, I have the power here, and then the ground, and in the middle of the yellow cable, that's what is reading my analog to digital value. And so we can go ahead and get rid, actually, we won't get rid of it. We're going to comment this out. And we're going to comment this out. And we're going to set my, analog to digital pin to a value. So we're going to say that's the potentiometer pin. I'll just say pot pin. We're going to set that to A0. Alrighty. And then next step, like I said in the setup, you want to set your pin. And so for this pin, it's going to be an input because we're reading the value from the potentiometer. And so our pot pin is going to be an input. I mentioned to all you guys earlier that you can use what this thing called the serial monitor is to act like a console, how it is in other IDEs, to print out values to it so you can see what the actual values are. So we're going to try to do that right here. So in the setup, you need one more thing, and you need to start the serial monitor. And so you do serial.begin. And it's worth mentioning, you know you're doing something right in Arduino if you're, ooh, I didn't realize this was touchscreen. That's okay. You know you're doing something right in Arduino if the letters highlight. If the letters don't highlight, unless like you declare them yourself, then you might want to check your pre-made functions on the Arduino link. And I'll send that out later as well. And we want to pass in how many bytes we're going to send to the serial monitor. So usually, here, the serial monitor's up here in the top right. Yeah, 96 baud. Is you want that number to be the same number you pass into the serial.begin. So that's what we want to see. Let's X out of that real quick. And then we're going to come down here. And okay. So like I mentioned, the potentiometer pin reads a value between 0 and 123. So what we want to do is read that value to start, and then maybe print it out to the serial monitor so we can get an idea of where the values are at on the potentiometer. So what do you think the first step I should do is, as far as putting it in the loop?
Don't look at me.
Console.
Yes, so you need to print to the console, but what do we need to do? What are we printing to the console?
Read it first.
Exactly. We need to read the value. This guy knows what he's talking about.
You should teach micro.
Yeah, literally. Okay, so as you saw earlier, we did a digital write function to output voltage to a pin. So maybe digital read, but we're actually not reading digital, we're reading analog. We're converting it to digital. So you can probably infer that this is going to have something to do with analog read, maybe analog read. Type that wrong. And it highlights, so we're good to go. And we're going to analog read our pot pin. This just passes in, what pin are you analog reading? And we're actually going to set that to a value. And so I need to declare this value up here. Int, we can just call it pot value. Now let's just declare it, and then we'll set that equal to our analog read. And so now, as Nick was saying, we want to print out this value to the serial monitor just to kind of see what we're getting. So let's do serial dot print line, and we're going to print our pot val. And it's just as simple as that. To use a serial monitor, you just start it in your setup, pass in how many baud you want to use. Just make sure it's the same as the serial monitor in your IDE. And then when you want to print something, you just use serial.println, and that will print a new line for every value you want to make. So let's go ahead and save that. Let's go ahead and compile it. Make sure it's all running right. It looks like it is. So now we can go ahead and upload it. Okay, and the serial monitor is not going to come up on its own. So you're going to have to, oh, you know what I forgot to do? This microcontroller is so fast that it's just going to print all those numbers out. And sometimes it's a little too fast for your serial monitor. So let's go ahead and put a delay function at the end of this and pass in 500 milliseconds so we can kind of see the values as they're changing. That's a half second. We can even do a second too, but I'll go ahead and upload this. And then we'll go to the serial monitor. It takes a little bit to get going, so hopefully it'll start. There, as you can see, oh, yeah, I'll grab my zoom. It's at 0 right now. So I'm gonna turn it. Oh.
No, the
Oh.
screen.
Oh, okay. As you cannot see that. Okay, it's at 0. It's gonna keep printing 0. Okay. This is not working. This is why I wanted to use my potentiometer. This is why I wanted to use my potentiometer that I practiced before I got here. But that's okay. So just like anything, we're just gonna have to do a little debugging. And that actually brings up a really good point. In software, debugging is right here on your computer. In electronics debugging, well, depends on, it's two places. It's in the hardware and in the software. So you got to think what's going on. I can almost guarantee it's in the hardware with this one because this potentiometer right here, it was printing out 0, but it's only what it's printing out. So I'm going to let's try flipping this bad boy.
So, do you have for power? Is it still connected to the 8? Or is it 5 volt?
For power, that might be a very, very good point.
So if you're not outputting the 8 pin.
There you go. See, Colby's actually thinking. And that, my friends, is what we call debugging with embedded systems, which basically just means hardware and software. And so let's actually change that real quick. Let's put our original 8-pin to 5 volts over here. That plugs in that, but it also, hopefully, yep. So you can see there's values now. So I'm going to turn the potentiometer, and you're going to see these values change. I'm going to go down to 0, and I'm going to go all the way up to the max it can go.
What was the problem? The power is still on the 8 instead of just 11. And if we weren't out,
Yes.
that's why.
And so now you can see, thank you, Colby, that it's working. So we can scroll around a little bit, mess with it around. Not very interesting numbers on the screen. You can do that in Python every day of the week. But let's use what we learned about the potentiometer. I'm going to close the serial monitor real quick. And the LED to kind of change the brightness of the LED if we can. And we're at 2:13 right now, so we got about 15 minutes to do this. It's not going to take that long, hopefully. Fingers crossed. It better not take that long. But, okay, so when Colby said move the 8-pin to 5 volts, that powered the potentiometer. But now, well, the LED is obviously powered, but that's because it's on that power rail that we made. And so we should probably take this LED off the power rail and make it go back to 8. So we can do something like that. And as far as that, we should have everything in our actual circuit hooked up. So now we just need to dive into the code. We will actually end up probably deleting all this. And we want to set up our pin mode again. And we want our LED to be pin 8 again. And I'll go ahead and put this down here just for the sake of neatness. And so right now we have our value, our analog read, it's going into the variable pot value. We're printing the pot value to the serial monitor, and we're delaying 500 seconds. And so we run into a little issue here. The RGB value of this LED is between 0 and 255, but the value in the potentiometer, the range for that, is between 0 and 123. So how can we get that range proportional to the other range? You guys have any ideas? Me neither. So I'm just going to divide by 4 because if you divide 123 by 4, it gets close enough to 255 where it's not necessarily proportional, but it gets close enough. And so we're going to do, let's see here. We're going to do LED. Oh, I need to declare a new value. So we're going to declare int LED val. And we're going to say LED val is equal to pot val divided by 4. And then we're going to try to remember what to do right here. So we have our LED value. We have our LED. How do we want to basically place this value on the LED so when we dim the potentiometer, or when we turn the potentiometer, it dims and brightens the LED? Can anyone think of a function for that? No, but we will get into that. Future lectures. We're actually going to use, if I believe this is right, we're going to use, I think digital write only takes in 2 parameters, high and low. I think analog write takes in a range. So if we use analog write and we pass in our LED, we want our, not LED val, but when we pass in our actual red LED, and then we pass in the LED value, the range, that kind of range between the potentiometer and converting it to the RGB range for the LED. Then we will get actual like conversion rate. And so now when we change the potentiometer, we divide it by 4. So if it's at 123, it will be roughly the brightest LED can be at 255. and it will be proportional as you divide by 4. And so let's change this delay to around 100 milliseconds, maybe 200, just for kicks. And so that should be enough to get a conversion rate between our potentiometer and our LED. Can anyone think of anything that we're missing? No? Me neither. I'm gonna compile this. So we have no compile issues. Let's hope to God that when we upload this, this will work. And so right now, what do we have? This is printing out probably wicked fast if it's printing out at all. Okay, it's actually not that bad. So we have 0. Yep, sorry. We have 0. Wait for this LED. Oh. So it's kind of on and off right there. So you can see it's not really dimming, but it's just going, it's hitting a certain threshold. It looks like 532, and it's just turning on. So we're obviously not using something correctly. So let's turn this off.
Yeah.
A minute 30. Okay, we're about to speed run this. Okay, let's debug this together. Analog write takes in our pin and our LED value. Pop value divided by 4.
Is LED pin. Can you do a digital pin? Can you do analog write on the 10?
Ah, that is a amazing point, Colby. That's great. As I mentioned earlier, Colby is just going off this today. Let's see if we can get this done. How much longer we have?
Less than a minute.
Okay. All right, guys. Utilities over here mean that this is an analog pig, analog pin. Obviously, this 8 doesn't have a tilde. So let's move this to 9, which does have a tilde. That means you can read analog values on it now. Let's change this parameter up to 9. That's why we made the parameter, so we can just change it in one place. Save our code, upload it, and let's see if this works better. So now, I can see it working. So I'm going to slide this over. We got 32. Look at this. It's barely coming up. And it gets brighter and brighter until it's the brightest it could possibly be at 123.